Hello, you're welcome. All right, so now we are looking at partial fraction, right? So what is a partial fraction? Now, in a simple term, okay, a partial fraction is simply a all right, part of a fraction, or a fraction that is actually split into its part, right? Part of a fraction. Now, so knowing that, how do I actually explain, okay, partial fraction being part of a fraction? Now let's now look at a fraction of, let's say I have 1 all over 2 plus 2 all over 3. Okay, if you are to solve this part fraction, of course, to simplify this fraction, you have 6, okay? That's gonna be 3 plus 4, right? Which of course is 7 all over 6, okay? So this is a single fraction, but okay, so it is these two components or these two fractions that gave rise to this. So if I actually return back, split this fraction, look at what I'm gonna have. So that is it is this now, these two, right? These two fractions, 1 over 2 and plus 2 all over 3, are the partial or the parts of this particular fraction, all right? So parts of a fraction, I think that's the best the best word, parts of a fraction. So now I just use numerical fraction to illustrate this, okay? But in partial fraction, we use is basically algebraic fraction, right? For example, okay, I will illustrate this using an example. Okay, example, you'll be given express. The question comes like this: express, right? 2 all over x plus 2 and x minus 3 into partial fraction. Okay, into partial fraction. All right, so now solution. Now to split a fraction into partial fraction, okay, look at what we do. Now you know very well that, okay, for me to split, okay, this fraction into partial fraction is going to give me two fractions. This fraction will eventually give me two fractions in which, okay, the denominator of one fraction, all right, let me write that very well, in which the denominator, okay, of one fraction is x plus 2, one of the fraction, and the denominator of the other fraction, okay, will be x minus 3. So now I know that this is the denominator of one and this is the denominator of the other fraction, but what I don't know is what the numerator is. Okay, so this idea is to find the numerator, okay, of this of the fraction that is denominator is s plus 2, and of course and that of s minus 2. So I don't know what it is. I use a, so I would not simply say this fraction is equivalent to this symbol of equivalent to a all over, of course, s plus 2. Right, then plus another numerator which I don't know what it is. I'll call it b all over x minus 3. Okay, so the whole idea is just for me to find, once I can find this numerator, yes, I have actually solved this partial fraction. So how do I do that? So the very first thing I'm going to do is to simplify this, okay, these two fractions into one fraction, and of course you know the LCM of the denominator is x plus 2, right? X plus 2 and x minus 3. So don't forget this 2 all over x plus 2, right? And x minus 3. Alright, so let's start dividing. S plus 2 divide this. S plus 2 will definitely cancel s plus 2. I'm left with this. So this is going to be, and I use what I have to multiply the numerator a. So that's going to be a times x minus 3, then plus the same thing happens here. S minus 3 divide the denominator here. S minus 3 actually cancels S minus 3. I'm left with this, so I will have to multiply it by by a, right? Am I making a mistake? Just divide. Okay, that is, yeah, a. All right, that's what am I doing here? Okay, S minus 3 divide S minus 3. I have S plus 2. I use S plus 2 to multiply b. Okay, please. That's it. So I have b multiplied by S plus 2, right? Okay, so you discover that I now have two fractions at both sides of the equation, and they have the same denominator. Okay, so by simple simplification, the denominator of both sides will cancel out. So I bring down the numerator. So 2 is equal to a open bracket x minus 3, then plus b, okay, x plus 2. So now remember, the whole idea of this for me to find a and b, right? So I have two unknown in just one single equation. How do I get a? How do I get b? For me to do that, okay, I will employ this very simple technique of eliminating one of the variable, one of the numerator, either a or b. So anyone I choose to eliminate, all I just need to do just to make that particular, the bracket that's attached to that particular variable, right, to be equal to 0. So let's say I want to eliminate a, so I have to make the bracket attached to a to be equal to 0. How do I make bracket attached to a to be equal to 0? I have to make x, okay, I have to put x to be equal to 3, because I know that if s is equal to 3, 3 minus 3 is 0, right? So let's do that. So any place I see s, I put 3. So I'm going to have 2 is equal to, open bracket, 3 minus 3. Then plus b, open bracket, 3 plus 2. So with what we have here now, we have that 3 minus 3 is 0. 0 times a is 0. So a have been eliminated, so I have 5b. So invariably now b is going to be equal to 2 all over 5. All right, I haven't gotten my b, then I need to get my a. How do I do that? I still apply the same technique, okay? To get my a, I have to eliminate b. So by putting, okay, x to be equal to minus 2. If I put x to be equal to minus 2, definitely, okay, b will be eliminated. So let's do that. 2 equal to a. Any place I see x, I put minus 2, right? Minus 3, okay. Then plus b, 2 minus 2, okay, plus 2. Plus 2, okay. So with what I have there, you can see that this is 0, b is eliminated. So I'm left with 2 is equal to, right, minus 2 minus 3, that's minus 5. That's going to be minus 5a. So that now makes a to be equal to 2 minus 2 all over 5. All right, so I've gotten it now. So invariably now I have my answer now becomes the partial fraction of 2 all over x plus 2, right, and the x minus 3 is equal to a, which of course is minus 2 all over 3, okay, divided by the denominator, which of course is x plus 2, then plus b, which what we have is 2 all over 5. Oh, please do this, minus 2 all over 5, okay. 2 all over 5. Then divided by x minus 3. So as simple as that. You can see, express this like this. This is going to be minus 2 all over 5, okay, open bracket, x, because x plus 2 is still the same thing, then plus 2 all over 5, all right, x minus 3. As simple as that. Let's look at another example. Let me clean up, okay. Now sometimes it might be the fraction also might be given, okay, example might be given of the in this form. Okay, express okay. So let me put that very well. Okay, example, resolve into partial fraction. All right, so we're resolving this into partial fraction, right? So solution. If I want to resolve it into partial fraction, I need to factorize this. Of course, this is a quadratic factor, right? So that I will have to, at least I need to have factors in the denominator, not just a function, right? So, and of course, if you should factorize this, factorizing x squared minus 2x, right? To factorize this, of course, you know how you do that. Multiply the first term and the last term, right? This is a quadratic factor. So they have what I have is s squared. So I'm splitting s squared into two factors, okay? So that at the end of the day, the two factors, if I add the two factors, supposed to give me the middle term, which is minus 2x, okay? Let's try x. S times x, of course, will give me s squared. But if I add s plus s, it will not give me minus 2s. So it's only when I put minus minus, right? And of course, minus s times minus s is plus s squared. And minus x, if I'm adding it, is going to minus 2s. So these are the two factors I'm looking for. So putting that into this, I'm going to have s squared, right? I replace, and of course, these two factors will replace the minus 2s because, yeah, when you add them, it will give you minus 2s. So I replace that minus 2 minus x minus x. I'm replacing minus 2s by minus s plus minus x, then plus 1, right? So now I cannot factorize this um I cannot factorize these four terms, okay, by binomially, okay, taking two term at a time. So I'm factorizing s squared minus x. Of course, what is common between s squared and minus x, that is x, open bracket. Of course, the other factor, put it inside the bracket. Then for this is going to be 1. So what is common between minus x plus 1? Minus 1 is definitely common, right? Minus 1 is definitely common. So, and of course, if minus 1 is outside the bracket, okay, so that means I have to put x inside for this, because minus 1 multiplied by x will give me minus x. And okay, for me to be able to have plus 1, that is minus 1. Okay, so this are the this is this in these two terms, okay, one bracket, a bracket is common, s minus 1 is a common bracket, so I take it out, open on that bracket, then the other factor is x and this factor is minus 1. So just discover that this is s minus 1. This expression, okay, after factorizing is giving me s minus 1, which of course is going to be x minus 1 square. So invariably now, in terms of factors, okay, what I'm factorizing is 3x minus 1 divided by x minus 1 square. Now I want to seize this opportunity to illustrate how we factorize uh, squares or powers of an expression. Okay, if we are to how to not factorize, how to resolve powers of an expression into partial fraction. If you are being given a power of an expression like us you have here, s minus 1 square into partial fraction, you are going to have the partial fraction goes this way, a all over first s minus 1d first degree, okay, you are going to arrange the partial fractions in increasing power of, okay, of that particular expression till you get to the highest power. The power is 2, so I'm going to start with a all over s minus 1, that is to degree 1, okay, to the power of 1, then plus, then b, okay, x minus 1 square. So it simply means that if it was raised to power 3, I have to go again to see s minus. So you in ascending order till you get to that power. I hope you understand that. I will still bring more example. Okay, so that is exactly what I'm resolving. Okay, so if I'm resolving this, you know what we do. This is equivalent to this. I have to LCM of the denominator is x minus 1 square. Okay, so I start dividing s minus 1 squared divided by s minus 1. I will just have s minus 1, then s minus 1 multiplied by a. All right. I have s minus 1, right? S minus 1 squared divided by s minus 1 squared, I have 1. Okay, 1 multiplied by b, I have b. Okay, so this is gonna be 3x minus 1 divided by okay, x minus 1 square. This cancels this, so I have 3x minus 1 equal to a plus b. All right, so if I put x to be equal to 1, this bracket is 0, so that means that's going to be 3 times 1 minus 1 equal to 0, then plus b. So that will make b to be equal to 2. All right, and if I want to find a, so I cannot eliminate b. Simply, all I will just, for me to get a, I will do coefficient comparison. Okay, what I mean by coefficient comparison, 3x minus 1 is equal to ax. I open this bracket, okay, minus a plus b. So if I'm doing coefficient comparison, okay, the coefficient of s is a, and the coefficient of x at the right hand, the coefficient of s here is 3. So that simply means that a is equal to 3. Okay, so of course I have to do coefficient comparison because this doesn't have a bracket for me to eliminate. Okay, so there are two ways of doing this. It's either you actually find your variable, your numerator, by elimination, or you find it by using coefficient comparison. Okay, definitely we're gonna look at more questions. So invariably now my b is 2 and my a is 3. So the partial fraction of 3x minus 1 all over, okay, x minus 1 all square will give me a, which of course 3 all over x minus 1, then plus b. Okay, what's b? B is 2 all over x minus 1 all square. All right, so we look at the proof to this and some other method of resolving partial fraction in the next video. See you in the next video. Thank you very much.